So we're here in 129S, and today we're going to talk about access controls and the first part of data stores. So the access controls should be here, and there they are. All right. So you have to authenticate people so you know who you are, and then you have to have session management where you keep track of who they are as they make requests and responses and wander through your application. So then you have access controls. Once you know who somebody is and you remember who they are, then you have to decide what they're allowed to do. That's access controls. You have some list of users, and certain users are allowed to do things and they're not allowed to do other things. You have to remember to test it for every request and operation, and this is the most common flaw. You just forget to test the access control, because if you do this, you won't probably notice. When you go and do things, it'll work. And this seems to be the most common flaw of APIs, and a lot of these, they just forget to enforce access controls for some activity. So the common vulnerabilities are vertical, horizontal, and context dependent. Vertical escalation is where you can move from an account to an account with higher privileges, like moving up to administrator. Horizontal is where you move to another account with the same privileges, like from one user to another. And business context dependent is where you just do things that shouldn't be possible in context, like performing tasks out of order or purchasing a product, skipping the step where you pay for it, that sort of thing. And like I say, the most common flaw is completely unprotected functionality. There is some action that you can do on the server, like change a password or create a new account or something, and they just forget to verify that you've logged in as the appropriate account, probably administrator, to do that, and you can just do it without permissions. I've come across these, everybody's pretty much come across these. Happens all the time. The OWASP calls it unsecured direct object access. You can access some object on the server, like a script that does something, without first proving that you are an authorized user to do it. So you just go to like an admin page or do an admin menu.jsp script. Somewhere on the website, there's a page you can get to, which really should make you log in as administrator first, but it doesn't. So you all you need to do is find those URLs that are privileged. You may not be able to find a link to them, but you can be able to find in the code. Here's something that's going to add this stuff to a URL. It's going to add new portal user2.jsp, that sort of thing. So you find out what their naming convention is, and you can guess what some of these are. Now you might have an identifier for a document passed to a server where it just says view document and then has document ID here. And then you might just be able to, this might not enforce any permissions for this. So you could just change this document ID to get to another one. This is the kind of thing that happens. In general, most of these flaws occur when the company is not very well organized, which is very common because you have different teams building things, and then sometimes you acquire another company and try to integrate their stuff into your stuff, and it doesn't really integrate very well. So you end up with some kind of authorization server, but the authorization server is not really integrated with all the applications. So instead of doing all of the work, going through all the work of integrating that, you do something quick, like just pass a parameter over to the other server, and in this parameter, you figure if they know this parameter, then that proves they've logged into the other server, although it doesn't really prove that. And that's the kind of thing that happens. So they may be predictable. The URLs might not be secret. Since the other server doesn't know you're treating that as authentication, it might be visible in logs or somewhere else in an app. It may sound stupid, but this is the chaos of a real business. Real businesses are constantly changing. You're constantly adding new features. You're constantly connecting to new cloud-based services and new business partners and sending data back and forth. You know, it's just sort of like a city where people keep building more roads and houses, and you know, they aren't very well integrated into the system typically. You can also have multi-stage functions. Select new user, select department, select role, then enter username and password. And you might only enforce access control for the first step and then not think about enforcing it for every page after that. So the result is you can skip steps and escalate privileges. And here's another one. They pay for a book and then they get a download link, but they don't actually verify that the users on the download link have paid for the book because, of course, that's difficult to do. You might have just one server with all your books, and then you have some other server where they pay money, And you don't really build the system like a database where you would know how many users have paid for this particular book. Rather than doing all that, you just give them a long number here and assume that only if they know the number, that's enough authorization to see the book. And you might want to accept that, saying I'm going to accept a certain amount of unauthorized downloads of the book rather than build that system. But that should be an intentional business decision you decide to make, especially probably unwise these days, because once somebody finds a URL to a good book, they'll put it on a social network and everybody will find it. But anyway, it's another form of insecure direct object access. And then, of course, you can have access to URLs restricted, like only administrators can go into the admin path. The problem is the way this is actually implemented in software on servers tends to be defective. Especially if you think about Apache servers, often you will enforce this, but only for certain requests, like GET requests, and not think about other requests. So there are, you can play with the verb. You can, if you use GET, then only GET might let you do something when they only thought about using POST. Head might work. And if you misspell the verb, it's just treated as a GET, but it might not be recognized by the security control, that sort of thing. So there's other ways people try to control access based on a parameter, based on the referrer field in the header, based on the location, and all of these can be bypassed in various ways. The parameter-based access control will be a privilege level and a hidden cookie, like admin equals true or something. And of course, if the attacker can just use a proxy like burp and change that, so change the admin equals true instead of admin equals false. If you pay attention to the referrer is just automatically added from the page you came from, and if it's not verified anywhere, and again, you can just change it with burp. So if having a certain value in the referrer matters, you can modify that field. And location restrictions are common. You can only view a sports event or a TV broadcast in a certain country. So lots of people know how to bypass these. You can get a proxy that lets you send your traffic to another country and appear to come from that country. You can use a VPN to do the same thing. You can use a mobile device to be your internet connection, and it might come out in the other country if you have a phone from that country. Or you can just manipulate client-side message instances for geolocation if you can find them. You may be able to manipulate the way the browser thinks where it is and that sort of thing. So I mean, this may be useful to you, but you have to be aware that it's not perfect. There are ways around it. And so if you want to find these kind of flaws, you can use burp. Burp will let you go to a page when logged in as administrator and then when logged in as a different user, and then color code what parts of the page are different in these two cases. And this will help you find which functionality is actually only available to administrators, and you can see if some of the stuff that the administrator saw is in fact visible to non-privileged users. All right, so that's testing direct access to methods. You might be able to guess other methods. I've had ones like this where I'm going to a page and the page says it's login 2. So if I just go to login or login 1, I find an old version that's less secure, that sort of thing. And you can see if access is properly limited. This indicates the use of an IBM server, these names, these things, IBM Tracker Debug and such. You can guess the technology in use. So you walk through the app, go log as an administrator, and note the URLs, and then go into a low privilege user and see if you can access any of those URLs. That's one simple test. Log in as administrator, find sensitive things that really should only be done by the administrator, like creating a new account or changing a password, and then try other methods and see if they're honored. This is likely to happen with Apache because Apache's access controls do refer to which method is being limited, and it's often confusing to users and they don't do it correctly. Don't assume that anything that is secret will not be found. Don't trust any user-applied parameters. Don't assume they will access pages in the intended sequence. We've talked about this before. You need to enforce that by putting a random hidden field on every page that you verify to make sure when they go to the next page that they actually came from the previous page you wanted them on and not from somewhere else, like the burp repeater tab. And never trust the user not to tamper with data. Anything that comes from a user should be revalidated before you trust it. So best practices, document your access control. You have to get organized, which is the hard thing for a company. I know, especially at the speed of business, like they say. You're always trying to rush out new features for the next quarter or something, and there's spending time to actually organize your motions is often neglected. So you have to have a central application component to check authentication and access control, and everything has to keep using that same component. That's the only way to keep it under control. This is why Microsoft sells domain controllers. If you want to control a fleet of devices, you have to have a central point of control so you can organize it and control it all in one place. Otherwise, you will never get all the mistakes out of it. And so you can also restrict things by IP address. You can protect static content by using other authentication mechanisms like two-factor authentication and things like that. Don't trust anything from the client, revalidate it, and consider re-authentication or two-factor authentication for security critical functions. Many, many companies are just moving up to two-factor all the time. Almost all the companies I consult for are doing that now. It's becoming standard, which is a very good idea. And of course, log high privilege, high activity important events, like user password changes and such, so you have some way to measure if an unusual number of those things are happening, or if they're being done at the wrong time of day or from the wrong accounts. So central access control, as I mentioned, is enormously useful. Now all your developers can quickly understand what to do. Then you can maintain it. You can make changes, like if you decide your password policy has to change, or you have to remove some user accounts because they're fake or something. You can do it in one central place. You can adapt to new changes, and you make fewer mistakes. And once you get it working, everybody uses the same authentication system. Everybody universally understands this for Windows domains, and they really ought to understand the same thing for web apps. And so you need to have a document that lists all the things that can be done on your company, like, search, create an application, edit application, policy updates, and so on. And then you sort your users into categories of groups, and you say, what should they be allowed to do? What are they not allowed to do? And then you make sure that you test all the time to make sure they're really allowed to do this. This is the access control matrix, and you have to have it somewhere, and you have to enforce it. All right, and here's something I read about, turned out to be less important than I thought, but there was a time when people used this kind of, sometimes people did this. In PHP, they would have MD5 of the password equals this number. And in PHP, if you choose two equal signs, for some ungodly reason, that does not mean the things on both sides are exactly identical. You would need three equal signs for that. So in this case, it will evaluate this as a number, 0 times 10 to the 199 trillion or something, which is always 0. So putting in any password which has an MD5 starting with 0E followed by any other numbers will do it. So this is a strange situation. Turns out to be quite rare in practice, but it's one of those flaws you can get, where you think you're verifying that the password is correct, and in fact there's another way to satisfy this condition of code without really putting in the right password. A more realistic one happened to me in earlier versions of my automated scoring system, where I didn't implement the PHP substring function correctly, and some students found that if you just left the flag field empty, it would score that as correct. It is easier to make that mistake than you might imagine, that completely invalid input is treated as correct instead of being rejected. You have to test your code to make sure that's not happening. Anyway, let's try a Kahoot. We have chapter 8, which is here. All right, So what kind of attack accesses pages out of order? That's logic exploitation. It's a little bit vague because it's not a technical error in a line of code. It's not thinking through exactly how the pages of your application are connected. All right, how about reading another Gmail user's email? Yeah, that's horizontal escalation. You move from one user account to another user's account without having the correct privileges, without having the correct credentials. All right, which one is security through obscurity? Yep, that's unprotected functionality. It's like hiding a key under the mat. Something important is not blocked, it's just hidden, and you hope people won't find it. All right, what defense would you bypass with a proxy server? Yeah, an access control that's location-based. We were just talking about this on Pulse Security Weekly. There's a guy that says we shouldn't even call VPNs virtual private networks because they're really not used for that purpose and they really don't improve your privacy because the VPN provider can see what you do. What they do, though, is they let you bypass your local security policy so you can see content that's blocked or content that's geofenced. Anyway. All right, so let's try the first bit of the next chapter, which I split into two pieces. So we'll talk about data stores, and we've already done some SQL injection attacks here. So you've seen this SQL, XML, and LDAP are common ways to send information up to a database, and it's a high-value target typically. SQL injection used to be the #1 vulnerability responsible for more than 90% of stolen data. I think this is no longer true. I think unprotected Amazon buckets have exceeded SQL injection as even a more efficient way to lose vast amounts of data. But before Open Amazon buckets, this was the main way people stole large amounts of data because it's easy to do and you can often steal the whole database, millions of records. So the fundamental problem here is code injection, which we've talked about a lot in this class. You interpret a language where you execute code one line by line, and you generate that line by some kind of app, which can include user input in the line. SQL, LDAP, Perl, and PHP can all do this. So we did the ping injection challenge in the projects, I think. So you're only supposed to put in an IP or a URL, but you can put in a semicolon and add another command here, so you can inject extra commands in the language bash. Now, all they were supposed to do was get an IP address from you, but now you're able to inject bash commands and run them on the server. That's command injection. And if you have compiled languages like C, then it's more rare because you don't normally have any dynamic code. What you have, all the code is written by the developer and compiled, and you're running it, it's already compiled. It no longer is generating lines of code and executing them on the fly. Now you can do this, and we'll do it in the exploit development class, but you cannot inject code in a simple language like Bash. You have to inject the code in machine code, already compiled. So you have to learn how to do assembly in machine code, and as I mentioned, I'm going to be teaching a class in assembler, and it's included in my malware analysis and exploit development classes for that reason. So to bypass the login with SQL injection, the typical line of SQL will say select information from the users table where the username equals Marcus and the password equals secret. And the problem here is these things come from the user, Marcus and secret, and they're indicated, there's these apostrophes that determine it. So if I put in admin apostrophe dash dash, then that line of code will turn to this line of code. Select star from users where username equals admin, and this starts a comment, so it ignores everything else. So it does not check to see if the password is correct. It just lets me in as admin. And I demonstrated this in the Web Security Academy last week or a couple weeks ago. So that's a simple bypass. If you don't know the username, you can just put this in as the username. And now it will say username equals empty or 1 equals 1, and everything else is ignored. And this will therefore, where condition will always be true. The first part is probably false. There's probably no user with an empty name, but the second part is always true. So the compound condition is true. So it will select star from users, and that usually will log in as the first user in the database, which is typically the administrator. So you don't even need to know the administrator's password or the administrator's name if you can do a SQL injection. So that's pretty serious, and you've done the SQL injection projects, I think, that I wrote, and more importantly, you started doing the ones in the Web Security Academy, which are the better ones to do. So the union operator combines two select statements, and that you see the results. So if you do if you select one user, then you'll find this one user, Hoop Derp Derper. But if you put Herp Derper apostrophe union select, SSN, then it will find the username and then add social security numbers to it. We've seen various versions of this. This is where you use union to combine two select statements together. And the important point is, even if you're only putting in a name, you can use union, and now you can inject a select statement. So you have the power of injecting a statement to pump out any data. If you can just figure out the name of the fields and columns and tables of what you're trying to get, then you can get it. And all right, the pound is often a way to start comments. Sometimes you have to try these other things like dash dash or slash star in different environments. So union, you must have the same structure of both of these. I'll demonstrate this in the SQL in the Web Security Academy pretty soon. You have to know. You have to match number of fields and data types. So if it's a numeric field and you want to add more stuff to it, there must be just one numeric field there. All right, if you have the wrong number of columns, you'll see an error message like this. The use select statement has a different number of columns. And if there are different data types, then if the original data type is text, you can put numbers in a text field, but if it was numbers, you can't put text in a numbers field. So that may be a limitation. All right, and so here's a summary of the steps. First, you find the number of columns by trying to add, what they recommend is null, because null is something you can add to a field of any type. So select null, dash, dash, and then it will complain if the number of columns is wrong. So you try injecting null, comma, null, null, comma, null, comma, null, until you find out how many columns there are. That's the first thing. This is a series of queries that will tell you how many columns there are. And then you can find a string column by putting in A somewhere. Or after you figure out there's 3 columns, find out which column is composed of a string, and then you can pump whatever data you want into that column safely, knowing it'll take any kind of result. You can also do add version to find what version of the SQL software or other database software is being run. And there's a vulnerable college here. I found this years ago, where someone had already done this. They concatenated username and password and pumped it out. So you could just go to this URL and you would see the name of the user and the password hash. I couldn't get anybody at this college to care, and it vanished after a while. But someone had run an automated tool and logged this URL on a forum, which is where I found it. Anyway, so MS SQL is Microsoft SQL product. So if you search for name equals Matthew, you'll get a person named Matthew, which is fine. But and now you want to find the desired number of columns, so you try Matthew apostrophe union select null, %20 for spaces here. And after a while you find out there are 5 columns. You can select null, 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 and now you get an extra row with empty in it, meaning it read those nulls. So the query is actually selecting 5 fields, but it's not displaying them all. It's only displaying 2 of them, but it doesn't really matter. As long as you can see anything, you're on the road. Now you have to find the string column. So you select things like this A, null, 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 and you see the A there. So now you know you can control one of these columns, and you can see the results in that column. So if you want anything, you just have to ask for it to appear in that column. And so now you will select table name, column name, null, 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 from information schema columns. And now you're getting table and column names for all the things. So now you see there's something called users that has a field called username and another field called password. And that's, of course, a pretty good thing to attack. So now you can select username, comma, password, null, 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 and here you are, in usernames and passwords. That's the sort of thing we do, and we'll be doing it in the Web Security Academy. So let's try some more Kahoots. This will be 9A. Here. All right, so what SQL method combines 2 queries together? That's union. Good. All right, what's the purpose of this stuff where you inject some nulls? Columns. You put in a certain number of nulls, and when it succeeds, you'll know that's how many columns there are in the query, in the other query that you're unioning together. All right, what's the free open source database? MySQL, a lot of people are now using something called MariaDB, which is essentially the same thing too. All right. All right, if this succeeds, what have you learned? selected null, A, null. So if it works, you are able to put an A in the second column. That proves the second column can hold a string. All right. SQL with minus and another without minus. I didn't notice anything like that anyway. All right. All right. Oops. There we go. PK. All right.